All right, we are starting our chemistry unit. The first PowerPoint that we're going to go over is atoms. Okay, so make sure for your notes that you are doing Cornell notes. On the top right, write atoms, and then the TEKS for that is 8.5a and 8.5b. Draw your line or your squigglies for your essential or for any of your questions. You are going to write the essential questions down here, and then basically all your notes that you're going to be writing in this PowerPoint are going to be in that red box. It does go to the other side as well. I wrote all my notes down for this PowerPoint, so it took about 3 pages total, not 3 full pages. So go ahead and click the next slide once you set up your Cornell note lines. All right, the essential questions that you need to write down are: what is the basic structure of atoms? How is the atom's mass calculated? Which subatomic particles are electrically charged? Where are the 3 main subatomic particles located? How do protons determine an atom's identity? So go ahead and pause it here so you can finish writing those questions down. All right, what is an atom? The basic building blocks of ordinary matter, the basic unit of a chemical element, and consists of 3 basic parts: protons, neutrons, and electrons. Everything that I'm highlighting, I would suggest you highlight. So, consists of 3 basic parts: protons, neutrons, and electrons. For your questions that you can write on the side, I would write those questions that I underlined in the red. I would write that on the side, on that left side of your Cornell notes. So, the structure of an atom: it consists of a nucleus in the center containing protons and neutrons. The electron cloud surrounds the nucleus and contains the electrons. The rings are referred to as orbitals or shells. So just like the activity we done earlier this week, the nucleus is the one that contains the protons and the neutrons. The electron cloud surrounds the nucleus and it contains the electrons. The rings are referred to as orbitals or shells. Go ahead and pause it here to finish writing this down. All right, so there is no interactive notebook template since you're writing everything down, so you can go ahead and skip this slide. So our protons are positively charged subatomic particles. They're located inside the nucleus. It's included in the atom's mass. 1 proton equals 1 atomic mass unit, otherwise known as AMU. The atomic number equals the number of protons. It determines the element's identity. So once you're done writing this down, the stuff you should highlight: positively charged, inside the nucleus, it's included in the atom's mass. 1 proton is 1 AMU. The atomic number equals the number of protons, and it determines the element's identity. Go ahead and pause it here if you're still writing. All right, so our neutrons. There's no electrical charge, so they're neutral. So that's how I would remember that one. Don't get confused with negative, it's neutral. It's located inside the nucleus with the protons. It's also included in the atom's mass. 1 neutron equals 1 AMU. It may not always be the same number of the protons. So it's not going to always be the same number. Go ahead and pause here if you're still writing. Alright, so electrons, they are negatively charged and they are on the outside. It does not contribute to the atom's mass. 1 electron equals 1/2000th AMU. In a neutral atom, the number, so this is important. So I would highlight this, star it, box it, or make it bigger. In a neutral atom, the number of protons and electrons are going to equal the same. So a way I remember electrons is they're negative, they're bad, so we don't want that anywhere inside our circle. Okay, you don't want any bad vibes inside your circle. Go ahead and pause here if you're still writing. Alright, so we don't have a template for this printed out, so I really want you guys to try your best in drawing a ape and a man. You can just draw a stick figure. I'm not good at drawing, but if you can draw a man, that's great. You need to make sure that you are drawing this box as well. So the ape stands for the atomic number. So once you draw your picture, you have your atomic number equals the number of protons equals the number of electrons. Alright, once you draw your ape, for your man, you have your mass number minus the atomic number equals the number of neutrons. Go ahead and pause here so you can take your time writing this down. I would also make sure for this ape man, it's super important to remember. You're going to have worksheets on this. This is going to be on your test. You need to remember ape man. Alright, so we don't have a foldable printed out for this as well, just because paper costs us money and we only are allocated a certain amount of copies. I want you to draw the atom and just the protons in the middle and the charge, which is positive, and then write the charge, write the location, and write the mass, so that AMU. I want you to do that with neutron. Obviously there's no charge because it's neutral. Make sure you write the location and then the mass, and then you have your electrons. So make sure you're drawing your electrons on the orbitals. Make sure you have your negative because it's a negative charge. And just make sure that you're copying this whole thing down in your notes. Go ahead and pause here. Alright, so this periodic table shows all the different atoms there are on Earth. It's called the periodic table of elements. Remember, an atom is the basic unit of a chemical element. So for here, you can kind of quickly just draw a box and then label it periodic table. Go ahead and pause. Alright, so what can we tell about this atom or this element from the periodic table? We know its name, which is nitrogen. We know the symbol, which is N. We're going to label the atomic number and the atomic mass. So, the element's name, nitrogen, Obviously, you guys can see that. And you guys can see the symbol for nitrogen is N. The number of protons is also referred to as the atomic number. Let's go back a little bit. Oops. Okay. So, we have our symbol. Check. We have the element's name. Check. We have the number of protons because we know the atomic number. So if we remember Ape Man, we have the atomic number is going to equal the number of protons, which is going to equal the number of electrons. Okay, our mass is going to be this 14 right here. So when you see the 14, just kind of if you can come up with a way to remember that 14 is going to be the mass. If you can come up with something that can help you, that'd be great. But just try your best to remember that 14 is the mass. Sometimes you'll see that the atomic number is going to be in the middle, so that a way to help me remember that is kind of like a jersey is always going to be like in the center of someone's shirt. So atomic number is going to be that number in the middle, and the atomic mass is always going to be kind of a decimal. So if you have your atomic number, which is 7, and that equals the number of protons, as referred to as the ape, and then it's going to equal the number of electrons. Now, how do I figure out how many neutrons there are? I'm going to take, I know there's a lot of arrows, the mass, which is 14 here. I'm going to subtract that by the atomic number, which is 7, and it's going to equal the number of neutrons that I have, 7. So if you want to play that again, you can. Go ahead and pause it here. Make sure that you have this all written down. Make sure that you have this example written down of nitrogen, and you're drawing the box and you're labeling the atomic number, the atomic mass, the symbol, and the name. Alright, so for this quick action here, you're going to be working with the person that you're doing notes with, so the person you're next to or at your table with. Basically, I want you guys to work together to answer these questions. So carbon, figure out how many number of protons there are. For beryllium, figure out the atomic mass. You're going to figure out for the third one what the element is based on the number of protons. You can find that because the number of protons equals the atomic number. And then magnesium, so you're figuring out the number of neutrons. Now, make sure that you're paying attention here. You are going to make up 4 problems of your own, asking for either the element name, the number of protons, neutrons, and electrons. So you're going to recreate a table like this. Do not use these elements, so you're going to pick different elements, and you're going to leave one of those blank. So you're going to create this table on the whiteboards, so make sure that you can create it at least big enough for people to see while they're sitting down at their tables. Once you are done, we're going to have other people solve it at the end of class. So again, this should all be copied down in your notes, and then this part right here, the 4 problems on your own, should be created on the whiteboard. Alright, so instead of, at the end of the notes, creating a summary, you're going to answer these questions. And they are not yes or no questions. You actually need to describe and identify. Describe the structure of atoms, including the masses, electrical charges, and locations of protons, neutrons, and electrons. And then you're going to identify an element, or can you identify an element by its number of protons? So basically I want you to explain to me how you do that. Alright, so once you're done with your notes, you're going to make sure you get a stamp from me. If you don't get a stamp from me in your note section of your checklist, that means your notes did not meet the expectation. Go back to the video of what my notes look like. They should look like that. I didn't use a highlighter. If I had highlighters, I would use it. If you have pens, colored pens, you can use all different colors of pens. I have no preference. So again, make sure that you get a stamp from me when you are done with your notes.